No, we will get to complex, but right now we're going to start off with just graphing simple rational functions. Okay, so I want you to first think about like what's something that would be considered a rational function. Like maybe more specifically, what is a rational function, or what's the word rational
A
mean?
rational function is a function that's rational.
Right. What does rational mean?
Irrational.
Right. So it's not irrational.
Does that mean it's like it has just
Hi.
stable and like understandable?
Yeah. No, that's a great way to put it. That's probably like the exact definition of what a rational number is. The fact that things can be rational means that they can all be represented in the form of a fraction. Okay, so when we think about rational, it's going to be some term, we're just going to represent this with g of x over some other function h of x. So each of these functions are essentially separate functions just written over top of one another, which can be kind of confusing, which is why we're going to start out with graphing simple rational functions. Obviously, one of the main things here is going to be that your denominator cannot be 0. That would make this undefined, therefore not rational. Okay, so if you ever had a denominator of 0, that's going to mean that you don't actually have a function, you can't graph it. So what these usually look like, and don't freak out, they look a little weird. Let me use a different color for this one. We usually have two asymptotes. So those are the dashed lines in a function. This is called a horizontal asymptote. Why horizontal? Because it's horizontal. Right, horizontal like the horizon means a flat line. Then we also have what's called a vertical asymptote. It goes up and down. So I'm representing these by VA and HA. But again, I'll kind of put this. These are called your asymptotes. How many of you remember what an asymptote is? Kind of, just a little bit. Newsflash, or fun fact, this isn't actually your function or your graph. These asymptotes, what they do is they essentially hold your graph in. So on this portion of my graph, I have 3 points that I want to connect. These 3 points are right here. Okay, these are 3 points on my graph. And you can even bring these points a little bit closer together if you want. If you were to have graphed these without asymptotes, you would maybe start here and then just draw this line and go straight down through. Except asymptotes hold us in and together.
Can we have definite, can we like take a little note of what asymptote means?
Yeah, we can. I just said it, but it basically holds the graph together.
Thank you.
Miss Reynolds,
Yeah.
I can't see it with the red, like the word.
Okay, it just says asymptotes is all.
Yeah, well, I'm kind of blind.
Okay, that's all it says.
Raylene's waiting for you to let her in.
Yeah. Okay. Yeah. So what happens is if I were to connect these two dots, instead of them going straight through, you can't cross an asymptote. So when you hit it, you don't actually touch it. You get very, very, very close to it, and then you just kind of skirt up. And that's not super accurate because I went out a little bit. You just keep getting closer and closer and closer to that asymptote, but you can never touch it. Yes, that's perfect. Asymptotes are like little jail bars. You can't cross them, but you can get super close to them. So then obviously we have to keep going through to this point, and I can get very, 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 very close to that asymptote, but I can't touch or cross it. So these kinds of curves are very specific to rational functions. So we also have one in the lower left-hand corner. And again, when you connect these points, you get very close to those asymptotes, but you never actually hit them. So what we would say is this one gets, so I wanted to draw this asymptote actually along the y-axis, but I wanted to put it off a little bit so you could see it. So technically this is along the y-axis.
Can you draw the line? Line, and actually close the horizontal line?
Yeah, it can. The only reason I drew it a little bit to the
Because I
below
accidentally
it.
did that.
right, so that's okay. The only reason I drew it a little bit below and a little bit off to the side was so that you could see it. I technically wanted these to be on my axis, but then you wouldn't really be able to see it. Yeah.
Okay.
But hopefully that helps it. But these asymptotes can move. Okay, so one of the things you're gonna have to find when you graph these is the asymptote. It may be way up here for your horizontal. It could be way down here for your horizontal. Your vertical could be shifted way over or way over this way. One other thing that can happen is we can have these flipped. So this curve could be up top, which means this curve would be down bottom. They always have to be in opposite corners of one another. Are your minds blown yet or what? A little bit. Okay. So the reason that these are going to be called simple is because we're going to only have maybe one or two variables within them. So we're not going to like make these super, super complicated yet. Okay, let me erase this so that our people at home don't lose when we're writing. Okay. So the current form that we're going to use, and you know we like to always throw you some formulas for these, is y equals a over x minus h plus k. And this is basically just the form that rational functions will be graphed in. Okay, so you know before sometimes I would have given you like an ax squared plus bx plus c. We always like to give you like the general form that you'll see these functions graphed in. Okay. So when we're graphing these, there's going to be a set of steps that we have to try to do. The first things we're going to have to find are our asymptotes. Okay, there's going to be asymptotes at specific places. So the first one is you want to take your denominator and you're going to set that equal to 0. So in this case, your denominator is everything in the bottom of this fraction. So that's going to be x minus h, and you set that equal to 0. And you want to solve for x. Okay, when you do that, you will get your first asymptote. And specifically, that's going to be, I'm going to label this horizontal. Okay, horizontal meaning side to side. The second asymptote is even easier. You're just going to have y equals your k value. So whatever value is written way out to the side of the fraction, so not in the fraction, but to the side of the fraction, that's your k value, which gives you your vertical asymptote. Okay, I don't want to go any further yet. I want to take you straight into an example. Okay, so given, let's do y equals, I like that one. -4 over x plus 2 minus 1. We'll do that one. Okay. So given this, the first thing you want to solve for is your asymptotes, because I have to know where do those lovely dashed lines go. To find my horizontal, you're going to take your denominator, being x plus 2 equals 0. Okay, why did I do that one specifically? Again, take your denominator, set it equal to 0, solve for x. I'm going to label this H right now. So I want to know when I get that, that's my horizontal asymptote. All right, so we are solving, we get x equals -2. Oh shoot, I'm so sorry. I did these totally backwards. These are flipped. I knew that didn't sound right in my head. Can anyone tell me why I did that wrong? This is a great learning experience. Why would it be flipped? If you have an x equals line, what way is that going to go up or down? If I'm on the x equals 2 line or -2 line, yeah, very good. X equals -2 here, 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 and all the way back up here. So when you have an x equals something, that leads to a vertical line. I'm so sorry, that's totally my bad. Completely opposite. Let me change this to V. Is everyone with me now? Did I totally confuse you for the rest of your life? Okay. So how do I draw this x equals -2 vertical asymptote? I don't care if you use the same color, it's totally okay. I'm going to use blue just so I don't mess you up. But that goes along that x equals 2, and I put a curve in mine. That x equals 2, -2 line. We do asymptotes on our lovely dashed lines. So then what's my other asymptote going to be? We take y for horizontal, y equals k. What's your k value here? Good, -1. Do I have to solve or do anything fancy for that one? No, super easy. So because it's a y equals line, y goes horizontally, right? Because y equals -1 here, but also here and here and here and all the way out this way. There we go. All right. Are you with me still? That clock is super off. Okay. So that time. All right. After you found your asymptotes, when you're dealing with these simpler rational functions, all I'm left to do is find some points. So whenever I just have to make up some points for this, I'm going to resort back to an XY table. So what I want you to do is find at least 3 points on each side of your vertical asymptote. So if my vertical asymptote is at -2, what kind of x values might I put into the left of it? Yeah, we could do -3, -4, -5, right? Any 3 points to the left and to the right of my vertical asymptote. Think back to what that original one looked like. We had a curve here and a curve here. So I want to know what's happening to the left and to the right of that vertical asymptote. So we're going to input the x values, -3, -4, and -5. What about 3 points to the right of this horizontal asymptote? We could do -1, 0, and 1. Those sound pretty easy. All right, I want you guys to fill out this XY table. Do you remember how to? If I have an X value, how do I find the corresponding Y value? Oh, you remember this. It starts with an S. Yeah, substitution. Where am I going to put that -3? In here. What kind of a value is that -3? Yeah, it's an X value. So what variable do you think I'm going to put it in for here? X, yeah. So for that first one, it would be y equals -4 over -3 plus 2 minus 1. Do you guys think you can solve fractions like that? because I totally think you can. And you can leave them in any form that you want. Okay, I want you to take like 5 minutes or longer if you need. It's okay. I'll give you time. We hate fractions. I get it. 5 minutes to get this whole thing filled out. If you want to use your calculator, I'm okay with decimals. Doesn't matter to me. But take 5 minutes to try to get this filled out.
I have a question. Miss Norman.
Yeah.
Well, I'm confused where we're getting the number 3 from.
Sorry, what was that?
I'm confused where we're getting the -3 from.
So the -3 is coming from our XY table. We said we wanted to choose 3 points. 3 points to the left of our vertical asymptote and 3 points to the right of our vertical asymptote. So 3 points to the left would be -3, -4, -5. Jenica, I think you too. And then to the right would be -1, 0, and +1. Does that help?
Yes.
Okay. Oh, I heard that. I'm sorry. Come on. Count it. Yeah. Yes, yeah, that's a great question. Always, yeah. If you want, you could always spread those 3 points out or make them smaller. Like we could have done -3, -5, and -7 if you wanted to. Choosing them close together or further apart won't really make yeah, maybe. Yeah, you do have to. Yeah, okay. Once you get those points, feel free to start plotting them as well. Huh. Oh, you did it. Okay. I can see that. Divide. Calculator hacks, got all of them. Did you want this to be added before you divide? Or you want this to be divided before you subtract? Wait. Okay. No, no, no. Oh, shoot, that's one. That is the negative. There, that's better.
Miss Reynolds.
No.
Yeah, what's up?
Oh, wrong thing.
That's okay.
Is this right?
You should have a couple more decimals in there then. Oh, wait, no. Yeah, that's looking good. I can't see all the numbers, but you look like you're having the right decimals there.
Okay.
We'll check them in just a second. All right, finish up with that 1 more minute. Once you start plotting these, it's helpful to make sure you plot them as you go through. Because remember, we can't cross an asymptote. So if you got a point that forces you to cross one of your asymptotes, you likely messed up a little bit. So that's been some great discoveries some people have made. All right, I'm gonna ask you guys to be confident. What'd you get for -3? 3, good. Yell them out. 4, -4.
1.
All right, -5. That was 0.33. Repeating. -1. 0. Everyone get 1. And 1. Who didn't get 1? Good. Okay. So again, one of the things is while you're going through these, if you ever get a point that forces you to cross over your asymptote, something definitely went wrong. So check yourself on that. What's that? Doing? I didn't do these, am I? I did not. I asked for you guys. Oh, that's actually what I had too. Down on my paper. I didn't even look at it. All right, let's look at -3.
Oh.
0 in for x. We would have -4 divided by 2, which gives us -2 minus 1. You're right. Yep, that is -3. All right, so we go over -3, up, 1, 2, 3. That's our first point. Then we have over -4, up 1, and over -5, up just 0.3, so a very small amount. Again, when you connect these dots, never cross your asymptotes, but you can get very, very, very close to them. Same thing on this side, over -1, down to -5. 0, we get -3, and 1, we have -2.3. So you see that they kind of themselves form that curve for you. You just have to make sure you follow it. So Ashley asked a great question earlier, and she said, do we always go just the 3 to the left and just the 3 to the right? That's a great question. In general, especially with the more simple ones here, yes. But what if I had the 3 points to the left were still points way up here? Could I graph my function if my only points were here, here, and here? No, I'd probably have to find some more that brought me closer to my asymptote. But that's something we'll kind of get into deeper into the future when we get further into the more complex versions. How do you guys feel about these? You feel okay?
It just takes forever.
It does. It takes absolutely forever. There's one thing I want to kind of quiz you on. Do you remember anything about domain and range? A lot of people feel super insecure about it. We haven't done it this year at all. I think we touched on it, but not a ton. So when we're talking about domain and range, we're basically saying like, what are the parameters of this function? Like, how far is it going up and down? How far is it going left and right? And they have like specific terms for each of them. So the way that I remember this, and I don't like, it makes sense to me, it may not make sense to anyone else, but because of the fact that there's a G in range that dips down, I remember that as being Y values. Because range deals with Y values or how far up and how far down it goes. Do you like that? That's the only way I remember it, is because domain is nice and flat and it deals with left to right or X values. And range is the only one that dips down, and so it's Y. It's the only way I've ever remembered it in my entire life. Like, that's coming from a math teacher. So don't feel bad if you forget how these go. So tell me, when we're looking at domain, there's one place when we're going all the way left and all the way right that this function doesn't exist. Where do you think that that's at? What happens at this asymptote? Can I ever touch it? So do I ever have a point on my asymptote? All right, so that means we approach it super close from the sides, but we don't ever hit it. Is there anything stopping me from going left after that asymptote? After it, can I go right all the way? Yeah, so the way that we're gonna write this is we can go to negative infinity. That's a horrible infinity sign, I'm so sorry. But then when we're coming from negative infinity, we hit this asymptote. The asymptote is at what point? -2. Okay, go ahead and close that parenthesis. And open this back up. So then we pick up back at -2. Now I'm at -2, and I'm going to go all the way to the right, and I'm never going to stop. Right, nothing's ever going to stop me. So I go to positive infinity. All right. Yeah, that's such. There really won't be one. That's going to be more of like. That's different kinds of functions. So if you talk about like maybe step functions, it might be completely confined. But for the most part, you're always going to see the positive infinity. And then really, really, really quick, what do you think is going to be the same thing for our range? Right, we can go still from all the way down to negative infinity, all the way up. We just have -1. All right, remember we have let me stop this recording.